Hello and welcome back. In this episode we're going to be taking a look at the ConstrainedBox widget. This is similar to the sizedBox widget, however, whereas the sizedBox widget specifies a fixed width and height, the ConstrainedBox widget specifies a minimum width and height and a maximum width of height, rather than those values being fixed. You'll see our homepage contains a scaffold with an app bar. And what we're going to do inside the body of the scaffold is create a container widget. We're going to give it a colour of red, and for the purposes of this demonstration we're going to give it a fixed width and height of 100 by 100. Next, what we're going to do is wrap the container widget into a ConstrainedBox widget. And you'll notice the ConstrainedBox requires the parameter constraints to be specified. So we will specify constraints, which as you can see there are box constraints, and the box constraints allow you to specify a minimum width and height and a maximum width and height. We will take a look first of all at the minimum width and height. If we specify, for example, a minimum width of 50 and a minimum height of 50, you'll notice how nothing changes. That's because the container has a width and height of 100, and the constrained box that it sits inside requires the child container to have a minimum width of 50 and a minimum height of 50, of which the container satisfies. You'll notice if we were to increase the minimum width and height to 250, the container will grow to be 250 wide by 250 high. Moving on, we will now take a look at the max width and max height. If we were to specify a max width of 200 and a max height of 200, you'll notice that the container has a width and height of 100 because the width of 100 is less than the max width of 200 and the height of 100 is less than the max height of 200. However, if we were to decrease the max width and max height to be 50, for example, you'll notice how the container shrinks to be 50 wide by 50 high, because a width of 100 and a height of 100 violate the max width constraint of 50 and the max height constraint of 50. That's a brief look there at the min width, min height, and the max width, max height. Inside the box constraints class, you'll also notice several named constructors. These can allow you to simplify the creation of the box constraints. These named constructors consist of the expand named constructor, loose, tight, tight for, and tight for finite. We'll take a look first of all at the expand named constructor, which, as the name suggests, will, if the width and height are not specified, expand to have a minimum width, minimum height, and a maximum width and a maximum height of infinity. This means that the child of the constrained box will be as large as in this case, the parent, which is the scaffold body. You notice that you can optionally specify a width and or a height. For example, with a width of 200, you'll notice how the container will be 200 wide. And with a height of 200, you'll notice how the container then becomes 200 high. That's because in this case, with a width of 200 and a height of 200, this sets the min width and max width to 200 and min height and max height to 200. Using the expand constructor with the width and height here is essentially the same as calling the default box constraints constructor, specifying a min width of 200, a max width of 200, and then a min height of 200 and a max height of 200. You may recall, if you've watched the sizedBox episode, that specifying a min width and max width of 200 and then a min height and a max height of 200 is the equivalent of specifying a sized box simply of width 200 and height 200. Moving on, one of the other named constructors on the box constraints class is the loose named constructor. Now the loose constructor gives the box constraints a minimum width of 0 and a minimum height of 0. However, it allows you to specify the maximum width and maximum height using this size parameter. We'll pass in a size object with a width of 200 and a height of 200. And you'll notice the container drops down to be 100 wide by 100 high. That's because the loose named constructor here specifies a minimum width and a minimum height of 0, and in the case of this size object, a maximum width and maximum height of 200, of which the width and height of 100 of the container complies with. You'll notice if we dropped the width and or the height down to 50, that the container will shrink to be 50 wide and 50 high. That's because the constraints now in this case are a minimum width and height of 0 and a maximum width and height of 50, of which the container's width and height of 100 violates. Hence why the width and height of the container shrinks to be the maximum width and height of 50. This essentially is the equivalent of specifying the min width and min height of 0 and max width and max height of 50 using the default box constraints constructor. We'll also take a look now at the tight named constructor, which similarly takes in a size parameter. However, the tight named constructor specifies the min width and min height and the max width and max height to be whatever this size parameter is, whereas the loose specifies the min width and min height to be 0, the tight specifies the min width and min height to essentially match the max width and max height. You'll notice with those parameters of 50 and 50, width and height, nothing changes because the width of 100 and height of 100 of the container still falls outside the range of a minimum width, minimum height, maximum width and maximum height of 50. You'll notice, if however we were to increase the width and height there to be 200, the container will grow to be 200 by 200. That's because, once again, the width and height of 100 fall outside of the constraints of a minimum width, minimum height, and maximum width and maximum height of 200. Essentially, calling the tight named constructor with the size of 200 and by 200 here would be the equivalent of calling the box constraints dot expand constructor with a width of 200 and a height of 200, which likewise would be the equivalent of calling the default box constraints constructor with a minimum width, maximum width set to 200 and a minimum height and maximum height set to 200. Finally, last but not least, the type 4 and type 4 finite constructors. By default, if you do not specify the width or the height and they are null, then type 4 will use a minimum width and height of 0 and a maximum width and height of infinity. You'll see how the container width and height of 100 complies with those constraints because the width of 100 fits inside the minimum width of 0 and the maximum width of infinity, and the height of 100 fits inside the minimum height of 0 and the maximum height of infinity. Essentially, the name parameters there of height and width could be specified. If you specify a width of 200, you'll notice how the container then grows to be 200 wide. That's because in the case where we specify a width, the min width and the max width become 200. If we were to do the same with the height, then you'll notice the height of the container becomes 200, because when specifying the height, that means that instead of the height being essentially between 0 and infinity, the height becomes fixed at 200, the minimum height being 200 and the maximum height being 200. Essentially, with the width and height both specified, this is the equivalent of calling the box constraints.height, specifying a size of 200 by 200. This would be the equivalent, therefore, of specifying box constraints.expand with a width and height of 200, with the default box constraints constructor being specified with a minimum width and a maximum width of 200, and a minimum height and a maximum height of 200, which aligns with the constructor of the sized box, specifying a width and height of 200. So the constrained box really allows you to be much more flexible than the simple sized box. In fact, the constrained box will even allow you to specify the equivalence width and height to what a sized box would provide you with. However, it should be noted that the constrained box will also allow you to specify simply a minimum width, minimum height, maximum width, and or maximum height, allowing you more finer grained control over the widths and heights of your widgets. I hope you found this useful. Thank you very much for watching.